In this video, we're going to complete the KutaSoftware Infinite Calculus free worksheet differentiation with trigonometric functions, otherwise listed as chain rule with trigonometric functions. Now, before we jump into this, I'm just going to quickly review the derivative of our 6 common trigonometric functions. First, we have the derivative of the sine of x. The derivative of the sine of x equals the cosine of x. Next, we'll have the derivative of the cosine of x, which the derivative of cosine of x is negative sine x. The next derivative we'll go over is the derivative of the tangent. So the derivative of the tangent of x is going to equal secant squared x. So the secant of x, that quantity squared. Next, we'll go over the derivative of cotangent of x, which the cotangent of x is going to be negative, or the opposite, of the cosecant squared of x. Then lastly, I'll go over the derivative of the secant of x, and I'll go over the derivative of the cosecant of x. The derivative of the secant of x is secant of x times tangent of x. And the derivative of the cosecant of x is negative cosecant of x times the cotangent of x. So writing each of those within our notes or on this paper, we're going to now differentiate each function with respect to x, and we're going to be utilizing the chain rule. So number 1, we're taking the derivative of f of x, which is the sine of 2x cubed. So we're looking at the sine of 2x cubed and we're taking the derivative of that. So we're going to take the derivative of the outside function, and then we're going to take the derivative of the inside function. The derivative of the sine of x, remember, was the cosine of x. So the derivative of f of x is going to be the cosine of 2x cubed times the derivative of that inside function, 2x cubed. So that's going to equal the cosine of 2x cubed times the derivative of 2x cubed is going to be 3 times 2, which is 6. So that's 6x to the 3 minus 1, 6x squared. So our derivative in number 1 is 6x squared times the cosine of 2x cubed. And if you want to write out the chain rule, so f of g of x would equal the sine of g of x, and g of x we set equal to 2x cubed. So remember, for the chain rule, that's going to be the derivative of f at g of x times the derivative of g of x. So again, that got us the cosine of g of x, and then we plugged g of x in for 2x cubed, and then we took the derivative of g of x, 6x cubed. Here's the derivative of f of g of x, and here's the derivative of g of x. Now on to number 2. And number 2, y equals the tangent of 5x cubed. So we'll set y equal to the tangent of u, and u will be equal to 5x cubed. So doing the chain rule, dy with respect to u is going to equal the derivative of the tangent of u, which is secant squared u. But remember, we set u equal to 5x cubed, so we're going to plug that in. So the derivative of y with respect to u is going to be the secant squared of 5x cubed, and then we need to take the derivative of u with respect to x, which 5x cubed becomes 3 times 5x to the 3 minus 1, which is 15x squared. So for the chain rule, dy dx, that's equal to dy du times du dx. For dy du, we got the secant squared of 5x cubed And for du dx, we got 15x squared. So our solution for the derivative of y with respect to x in number 2 is going to be 15x squared times secant squared of 5x cubed. And that's our derivative in number 2. Moving on to number 3, again we're using the chain rule. So we're first going to find the derivative of the secant of u. And the derivative of the secant is going to be secant tangent. So writing this out again, if we set y equal to the secant of u and u equal to 4x to the 5th, then for the derivative of y with respect to u, secant of u, that derivative is secant of u times the tangent of u. But we know what u is. U is 4x to the 5th, so we're just going to plug that back in. So the derivative of y with respect to u is the secant of 4x to the 5th times the tangent of 4x to the 5th. But remember, dy du gets multiplied by du dx in order to find the derivative of y with respect to x. So now we're finding the derivative of 4x to the 5th, which is 20x to the 4th. So writing this all out, dy du times du dx, we're going to get 20x to the 4th times the secant of 4x to the 5th times the tangent of 4x to the 5th. That's our derivative for number 3. In number 4, y is going to equal the cosecant of u, and we'll set u equal to 5x to the 5th. So the derivative of y with respect to u is the derivative of the cosecant, which the derivative of the cosecant of u is going to be negative cosecant of u times the cotangent of u. And remember, we know what u is, so we'll plug that back in. And the derivative of u with respect to x is going to be the derivative of 5x to the 5th, which 5 times 5 is 25, and taking 1 away from 5 is 4. So we're going to have 25x to the 4th. So multiplying all of this out and plugging u back in, the derivative of y with respect to x is going to equal negative cosecant of 5x to the 5th times the cotangent of 5x to the 5th times that derivative of 5x to the 5th, which is 25x to the 4th. Now simplifying, I'll put this negative with my 25x to the 4th. So I'll have negative 25x to the 4th times the cosecant of 5x to the 5th times the cotangent of 5x to the 5th. That is my derivative in number 4. Let's continue on to number 5. For number 5, we're not only going to be using the chain rule, but we're also going to need to use the product rule. Here is our first function, and here is our second function. So dy dx, that's going to be equivalent to the first function, 2x to the 5th plus 3 times the derivative of the second function, which is the cosine of x squared, and that will be added to, because remember this is the product rule, that function of cosine of x squared times the derivative of the second function, which will be the derivative of 2x to the 5th plus 3. Now simplifying, we'll have 2x to the 5th plus 3 times the derivative of the cosine of x squared. We're going to need to do the chain rule for this, taking the derivative of that outside function, which is the cosine function, and then taking the derivative of the inside function, x squared. Remember, the derivative of the cosine of u is the negative sine of u. So I'll have the derivative of the cosine of x squared is negative sine of x squared, and then I'm multiplying that by the derivative of that inside function, the derivative of x squared, which is 2x, and that will get added to the cosine of x squared times the derivative of 2x to the fifth plus 3. This 3 is a constant, and the derivative of a constant is 0. And the derivative of 2x to the fifth, 5 will get multiplied by 2, and then that value of the exponent will decrease by 1. So I'll get 2 times 5, which is 10, times x to the fourth. Now simplifying, I'm going to distribute this negative sign to 2x to the fifth and 3. So I'll have 2x to the fifth times negative sine x squared, so that's going to be negative 2x to the fifth times sine of x squared, plus 3 times the negative sine of x squared is going to be negative 3 times the sine of x squared. And then I'm going to multiply all that by 2x, but I don't want to multiply that out yet because you can see in my second set of terms, I have the cosine of x squared times 10x to the fourth. I can rewrite 10x to the fourth, pulling out a 2x. So when I pull out 2x, I'm left with 5x cubed. 2x times 5x cubed is 10x to the fourth, and then I need to multiply that by the cosine of x squared. Now you may be asking, why did I pull out a 2x? I did that because I now have 2x in both terms, which I can pull out in front. So I'll have 2x times negative 2x to the fifth times the sine of x squared minus, because adding a negative is the same as subtracting a positive, so minus 3 times the sine of x squared, and then, remember, I'm adding this next term. So adding 5x cubed times the cosine of x squared. So again, my derivative at number 5 is now simplified, and I get 2x times negative 2x to the fifth times the sine of x squared minus 3 times the sine of x squared plus 5x cubed times the cosine of x squared. Let's continue on to number 6. In number 5, we use the product rule. In number 6, we're going to use the quotient rule. Remember, low d high minus high d low all over low squared. So remembering that, the derivative of y with respect to x will equal low, so the cosine of 2x cubed times the derivative of the high, which is the derivative of negative 2x squared minus 5, and then we're going to be subtracting the high function, or the function in the numerator, negative 2x squared minus 5, times the derivative of the function in the denominator, low, which is the derivative of the cosine of 2x cubed, and that's all over the cosine of 2x cubed squared. So now simplifying, we'll have the cosine of 2x cubed times the derivative of negative 2x squared minus 5. That 5 is a constant, so the derivative is 0. Therefore, I'm looking at negative 2x cubed, which 2 times negative 2 is negative 4. So that's going to be negative 4x. So we have the cosine of 2x cubed times negative 4x, and we're going to be subtracting negative 2x squared minus 5 times the derivative of the cosine of 2x cubed. Finding that derivative, we're going to need to use the chain rule. So we're going to do the derivative of the cosine first, and then we're going to take the derivative of 2x cubed. So the derivative of the cosine of 2x cubed, the derivative of cosine is negative sign, so that's going to mean the negative or opposite sign of 2x cubed, and we're multiplying that by the derivative of that inside function, the derivative of 2x cubed, which is 6x squared. So again, we're using the chain rule on cosine of 2x cubed to get negative sine of 2x cubed times 6x squared. And that's all over, I'm going to write as cosine squared of 2x cubed. Simplifying, I'll have negative 4x times the cosine of 2x cubed minus, I'll distribute negative sine x to each of my terms. So that's going to be positive 2x squared times the sine of 2x cubed minus a negative, so plus 5 times sine of 2x cubed, and that all gets multiplied by 6x squared. And remember, this is all over the cosine of 2x cubed, that quantity squared. So in my next step, I'll be distributing 6x squared to give me negative 4x times the cosine of 2x cubed minus 2x squared times 6x squared is 12x to the fourth times the sine of 2x cubed plus 6x squared times 5 will be 30x squared times the sine of 2x cubed. And that's all over the cosine of 2x cubed squared. Now one of my last steps I'm doing is simplifying my numerator. In my numerator, 4x, 12x to the fourth, and 30x squared all have a common factor of 2x. So I'll pull out a 2x in the front. So I'll get 2x times, so I'm pulling out 2x from this first term, this second term, and this third term. So negative 4x divided by 2x is negative 2, so that's negative 2 times the cosine of 2x cubed minus 12x to the fourth divided by 2x, which is 6x cubed, and that's multiplied by the sine of 2x cubed. And then I'm also going to subtract my next term, because remember, my subtraction is applied to that entire quantity. So I'll be subtracting 30x squared divided by 2x, which is 15x times the sine of 2x cubed, and that's all over the cosine of 2x cubed squared. That is my derivative of y with respect to x in number 6. 2x times negative 2 cosine of 2x cubed minus 6x cubed times the sine of 2x cubed minus 15x times the sine of 2x cubed all over the cosine of 2x cubed squared. Now on to number 7. In number 7, I'm going to need to use the chain rule multiple times. Remember, this cube is applied to the entire function sine of x to the fifth. So if you need to rewrite it, feel free to rewrite it as the sine of x to the fifth cubed. So what I'm going to do, I'm going to take the derivative of that outside function, which is my function cubed. Then I'm going to take the derivative of the sine of x to the fifth, and then that gets multiplied by the derivative of x to the fifth. So I'm applying the chain rule 3 separate times. So first, taking the 3, pulling it down in front, and then decreasing that value by 1, I'll get 3 times the sine of x to the fifth squared. Now that needs to be multiplied by the derivative of the sine of x to the fifth, which is the derivative of sine is cosine. So that gets multiplied by the cosine of x to the fifth. And then lastly, we have to find the derivative of x to the fifth. And the derivative of x to the fifth is 5x to the fourth. So now I'll simplify this to get my answer. So I'm going to combine 5x to the fourth times 3, which will be 15x to the fourth, and that's multiplied by the sine of x to the fifth squared. So the sine of x to the fifth squared times the cosine of x to the fifth. That's my derivative in number 7. However, because we applied the chain rule 3 separate times, if you want to, you can write that down. Essentially, we set f of x as x cubed. That was our outermost function. Then g of x we set as the sine of x. That was our next function. And then our innermost function, h of x, we set as x to the fifth. So we took the derivative of f of g of h of x, multiplied that by the derivative of g of h of x, and then multiplied that by the derivative of h of x. So this entire function is f of g of h of x. Because you can see, if we were to plug x in for h, we'd get x to the fifth, and then if we plugged h of x in for g, we would get sine of x to the fifth, and then if we plugged the sine of x to the fifth in for x in f of x, we would get the sine of x to the fifth cubed. So if you want to write out all the steps of the chain rule, feel free to write out those functions and help you do so. However, now we're going to continue on to the next function. In number 8, f of x equals the cosine of negative 3x squared plus 2 squared, and we're finding the derivative of that. Now I want to note that this exponent of 2 is applied within the cosine. It's not applied to the cosine function itself, it's applied within the cosine. So the derivative of this entire term, we're taking the derivative of our outside function, the cosine function, then we're going to multiply that by the derivative of our inside function, which is negative 3x squared plus 2 squared, and then after that we need to apply the chain rule again to take the derivative of the innermost function, which is just negative 3x squared plus 2. So starting with the outermost function, the derivative of cosine is negative sine. So we're going to have the negative sine of negative 3x squared plus 2 squared. That will then get multiplied by the derivative of that inner function, which in this case we need to take the 2, bring it down in front, and then decrease that exponent by 1. So that's going to be 2 times negative 3x squared plus 2 to the first. And then that quantity will get multiplied by the derivative of the innermost function, which is the derivative of negative 3x squared plus 2. This 2 is a constant, therefore the derivative is 0. And the derivative of negative 3x squared, that 2 will get multiplied to negative 3, and then the value of the exponent will decrease by 1 to give us negative 6x. So let's multiply this all out and simplify. We have negative sine of negative 3x squared plus 2 squared times, now I'll combine my 2 and negative 6. Multiplying those together, I'll get negative 12x times negative 3x squared plus 2. And then lastly, I'm taking the opposite of the sign, or you can think of this as negative 1 times the sign. So I'll combine negative 1 with negative 12x to give me a positive 12x times the sine of the quantity negative 3x squared plus 2 squared, and that all gets multiplied by negative 3x squared plus 2. And that's my final derivative on this worksheet. 12x times the sine of negative 3x squared plus 2 squared times negative 3x squared plus 2. If you have any questions, as always, put them in the comments below, and don't forget to like, subscribe, and share. If you want to show me even more support, become a patron. Go to my Patreon link in this video description, or go to my website, maemap.com, that's maemap.com, to find out more information.